So today we're going to be talking about probability, and we're going to get this party started with a definition. So in an experiment, the set of all possible outcomes is called a sample space, and we'll often denote this by S. So suppose you roll a six-sided die. If we wanted to determine the sample space, we just need to figure out the outcomes, all the possible outcomes of rolling that six-sided die. So in the case of a six-sided die, we just have the numbers 1, 2, 3, 4, 5, and 6. So S equals 1, 2, 3, 4, 5, 6, and that's our solution. And we can continue this idea. We can do another random experiment. Suppose we're tossing a fair coin and we record that top side. What's the sample space of this? Well, then we have two possibilities. We either have heads or tails. And we can continue this idea to some different examples, such as suppose you roll two fair six-sided dice and record the sum of the top faces. What is the sample space of this experiment? Well, in this case, we have two dice, and when you think of the lowest possibility on six-sided dice, it would be a 1 and a 1, and so that would give us 2 as our sum. And we can continue this process. We could get a 1 and a 2, which would give us a 3 as the sum of the two dice, and keep on going. And what would be the largest possible value? Well, it would be rolling a 6 and a 6, which would give us a sum of 12. So essentially we can list out all the values here. That would mean our sample space is just going to be the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so we've seen the sample space at work. Now let's build to the idea of an event. So an event is just a subset of the sample space. So assume we're tossing three fair coins and we record the top sides of the coins. First off, let's figure out what is the sample space of this experiment. And we're going to use some shorthand. H will denote heads and T will denote tails. And so what we could have is for our sample space, we could have heads, heads, heads. And now we can move along a tail. So we could do heads, heads, tails, and then heads, tails, heads, tails, heads, heads. So notice we're just moving that tails along the different positions there. And then we could have two tails and one head. And so we'll move the different positions for one head along each position. So tails, tails, heads, tails, head, tails, heads, tails, tails, and tails, tails, tails. So now let's actually add on to this. Let's find if E is an event, let's let E be that event where we get exactly one head. And what would that look like? Well, it's just a subset of the sample space. So we're just taking tails, tails, heads, tails, heads, tails, and heads, tails, tails. Those are our three different possibilities for getting exactly one head. And it's just that subset of that sample space listed right there. So moving forward, what we want to build to is this notion of probability. And so the probability of an event E, which we're going to denote all the time by P of E, where E is that subset of the sample space, is just the likelihood of the event occurring. And the formula for this is given by our number of outcomes associated with the event divided by the total number of possible outcomes. Okay? So let's take a look at an example, something we might be familiar with. Suppose you roll a fair six-sided die and record the top side. What is the probability of rolling a number greater than 4? So in this case, what we're looking for is a probability of rolling a number greater than 4. Well, that means our event E in this case would be corresponding to 5 and 6, because those are only two numbers on a six-sided die that are greater than 4. And our sample space is just 1, 2, 3, 4, 5, 6. And since each of these is a fair six-sided die, each of these would be equally likely. So there's no funny business going on here. So the number of outcomes associated with that event, as we see, is 2, and the total number of possible outcomes is 6, so that's 2 over 6, which is also 1/3. Okay, let's try a couple more examples to finish this off. So suppose you toss three fair coins and record the top side of the coins. What is the probability of getting exactly one head? So we've kind of seen this before in terms of the sample space in the event. So the probability of getting exactly one head, remember the sample space, we had 8 different options with each of those being equally likely, and the event would be tails, tails, heads, tails, heads, tails, and heads, tails, tails. And so notice that gives us 3 possibilities, and those are equally likely once again. So we have 3 out of 8 is our final answer for this problem. So it might just seem like we're counting the number of elements in the event and divided by the number of elements in the sample space, but that's not always the case. There can be a little bit more trickery to this. So suppose you roll two fair six-sided dice and record the sum of the top two faces. What is the probability of the sum of the two dice is 5? So in this case, if we're rolling a sum of 5, we need to go through all the different scenarios. So when we're listing out the scenarios, you can think about the different positions for each die. So we could do a 1 and a 1, or a 1 and a 2, or a 2 and a 1, 1 and 3, 2 and 2, 3 and 1. And we can continue this out. Well, when you think about it, we're going to end up having 36 total possibilities, as you can see listed completely out here to our right hand side. So with the 36 different possibilities, and that came from, there's 6 possibilities on the first dice and 6 possibilities on the second dice, so that makes 6 squared different possibilities. So we get our 36 in the denominator versus when we think of just 2 through 12, so you have 11 different positions there. So a little bit different than what we might expect because of not each of these are equally likely. And so now we want to figure out how many different ways can we roll a sum of 5. So we see all of these answers listed out over here. Well, if you look, we can do a 5 with a 1 and a 4, a 2 and a 3, a 3 and 2, or a 4 and a 1. And so that makes 4 different possibilities of rolling a sum of 5 out of these 36. And so if we simplify that, we get 1 over 9 as our final answer. And this just illustrates another method for calculating the probability. Just remember, you're always dividing by the total number of possible outcomes, and on the numerator you have the number of outcomes associated with that event.